Does that change what we know about that time period?
I think there was a lot more of these animals than we thought. Like going through and seeing like literally hundreds of mosasaurs now, I have a better sense that I feel like they're much more diverse than we currently understand them to be. So I think it's painting a better, more complete picture of. Yeah.
Now, you say that this fossil was originally found in Texas. What does that say to you about its original habitat?
So it lived in what was called the Western Interior Seaway. So during much of the late Cretaceous, the entire like middle of North America was covered by water. It was underwater. So there was a warm, shallow sea that connected the Gulf of Mexico to the Arctic Ocean, and it was home to all kinds of sea monsters, basically. It was a very different ecosystem in the water than we have nowadays. Like there's no whales, there's not really coral reefs in the same way that exists today. It was an ecosystem dominated by marine reptiles of all kinds. So mosasaurs, plesiosaurs, sea turtles, some sea turtles as big as a car. Parts of the seafloor were covered in like these giant flat clams that were like 1 to 2 meters across. All kinds of different fish that all have crazy teeth and faces and things like that. It was really a very different world, underwater and on land.
Well, if that inland sea went all the way up to the Arctic, how far north do you think these tylosaurs went?
The northernmost specimens that we have of this species in particular is in Kansas. Tylosaurs broadly, though, do range up into Canada. There's one that's not formally described. It was described as part of a master's thesis a couple of years ago that I believe is actually from the Arctic. But something to keep in mind is that Earth at that time was much warmer overall than it is now. Like, there were no ice caps at all. They did fully range through the whole thing. There were different species at different points. The problem is, like, we don't have a complete record from start to finish of all time in all places. So we're kind of piecing together a puzzle of where these things were, but they seem to have spanned the whole thing. And then beyond that, they have relatives that were in Europe as well as Africa and Antarctica and Japan and like literally everywhere.
Well, we have lots of dinosaur fossils here in Canada, so maybe we should take another look at our collections to see if they're in there.
Oh, absolutely. I know at least the Royal Tyrrell Museum in Alberta has a lot of really cool mosasaurs. Not too many tylosaurs. It's more of the later, a different group of mosasaurs altogether kind of is more common in their collections. But they do have one or two.
Why do you think this species sort of got by everyone? It wasn't identified before.
Historically, like, first of all, there's not many people that specialize on mosasaurs in this level of detail. And the ones that do exist are either in Canada or on the east coast of the United States. And so it's just farther to travel to go. You'd have to really go out of your way and be looking for them almost to make your way to Texas. And really the only reason I did is because I found that one at the em1, and I wound up working with someone on my committee who was based in Texas.
It makes you wonder how many other undiscovered species are sitting in those bone collections.
Oh yeah, a lot probably.
Well, now that you've identified a new apex predator in the waters 80 or 100 million years ago, how does that change what we know about that time period?
I think there was a lot more of these animals than we thought. Like going through and seeing like literally hundreds of mosasaurs now, I have a better sense that I feel like they're much more diverse than we currently understand them to be. So I think it's painting a better, more complete picture of those ecosystems.
Dr. Zietlow, thank you so much for your time.
Of course, thank you.
Dr. Amelia Zietlow is a museum specialist at the History Museum at the Castle in Appleton, Wisconsin. Okay, I've got my sleep mask, my sound machine, my humidifier, my duvet, my king-size bed, all to myself. I'm finally ready for a nap. Well, these days our social media feeds are filled with tips and tools to help us settle in and get a good night's sleep, but it didn't used to be that way. Our ancestors didn't have sleep apps or pillow-top mattresses. They slept on animal hides and tucked in when the sun went down. Sleep anthropologist Dr. David Sampson has spent a decade studying how we and our closest relatives slumber. He embedded himself with the hunter-gatherer Hasda people in Tanzania and climbed trees to siesta in a chimp nest in the forest of Africa to learn about how the way we sleep has changed over time. Now in a new book, he explores what we know about our million-year evolutionary quest for rest and how the way we sleep today is both helping and hurting us. Dr. Sampson is an evolutionary anthropologist at the University of Toronto, Mississauga, and the author of The Sleepless Ape, the story of sleep in human evolution. Hello and welcome back to Quirks and Quarks.
Thank you, Bob. It is a pleasure to be back.
What is it about sleep that fascinates you?
If somebody had asked me whether or not I'd be interested in sleep or become a sleep specialist about 10 years ago, I would have thought they were crazy. But once I realized that what we knew in terms of the scientific community and especially the evolutionary anthropology community, what we knew about sleep from the vantage point of evolutionary theory in human evolution was effectively almost nothing. We had these beautiful ethnographic reports, but we hadn't done any really broad phylogenetically deep analyses in it. And that's what made me really fall in love with the topic.
Well, considering how much time sleep takes up in our lives, why is it still so poorly understood?
Here's the question, and I love to open my course with this particular question. What is sleep? And the reason why it is a stumper for a lot of my students is that it's actually three different kinds of things. It's a behavior, so you have eyes closed, you're lying down, you have low motor activity, you have a high arousal threshold, meaning it takes a lot of stimulus in your environment to wake you up, which brings us to the second kind of thing sleep is. It's a brain state. There is distinctive sleep architecture that's been quantified scientifically since the 1950s. And we know that it goes through 4 to 6 different cycles, usually about 90 minutes each. And we spend about 75% of our sleep state in what's called non-REM. And this is deep, slow wave sleep. We do a lot of it in the early part of the night. And then the other quarter of it, which is REM, it is the place where we are most associated with dreaming. And we have a lot of it later in the evening. And then finally, it's a neurophysiological process. So things like the lymphatic system, where you have this basically fluid cleaning out the interstitial tissues of your brain and clearing out all that beta amyloid gunk that's associated with things like neurodegenerative disorders later in life.
Boy. And when you say REM, that means rapid eye movement.
That's correct.
And so it's actually doing things to our body. I mean, what's it doing to our health as we sleep?
Yeah, so remember I highlighted the non-REM part? That is what's most associated with this immune function and deep repair. Particularly, it is a place where memory cells, they match on to see what the invader is, such that when you're awake, you can produce the correct response to it. If you get under 5 hours of sleep, for example, the likelihood of getting the rhinovirus, the common cold, if you're exposed to it, goes up 80%. So there are some fundamental basic processes that especially occur in that deep, slow wave sleep early on in the night that are crucial for our health and our well-being, both short, mid, and long term.
Now, we typically associate REM sleep with dreaming, so how does that factor into our health?
Yeah, so REM is most deeply connected in terms of the scientific literature. It's most deeply linked to our capacity to emotionally regulate. And Matthew Walker, the sleep scientist, calls REM our nighttime therapist. So think of REM as that part of the sleep process that allows you to replay a traumatic memory or some really important event in the day, and to consolidate that information, stored it in the hippocampus for later retrieval, but then when you retrieve it, not experience the emotional valence of the memory. Effectively, if you don't get enough sleep, you're not going to be able to jettison the emotional content of the memory. This is why some of the leading cutting edge research with PTSD is looking at how to solve for sleep first, and then the PTSD heals itself because it's a process. So it's really kind of a way to emotionally regulate.
Now, in your book, you talk about what you call the human sleep paradox. Tell me about that.
Yeah, okay. So I'm going to ask you a question. Recall the last time you had really significant sleep deprivation. How did you feel?
If I have a bad night's sleep, I'm groggy. I can barely keep my eyes open. I find it hard to focus, keep a sentence together. I feel like I'm almost on drugs if I haven't had a good night's sleep.
Well, that's perfect. And that mirrors a lot of people's experience under sleep deprivation. In fact, you really highlighted the cognitive angle of this. So when we look at things like, imagine tool use or tool function. So if you're driving a car and you're under 4 hours of sleep, then you're driving effectively at the legal limit of alcohol, if you had to up the legal limit of alcohol. This is to say, we really need sleep for all the things that makes us human. But the paradox is, when we measure sleep in every single primate on the planet, humans sleep the least of any primate. You would think with our big brains and our big bodies, we would sleep the most. But no, owl monkeys do that. They sleep 17 hours out of the day. We are by far the least sleeping primate, and that's the sleep paradox.
So why do you think we would have evolved like this?
Yes, and that is the central question that I explore in the book. We often think of a good night's sleep as one that is fundamentally anti-social, and it's going to be this very minimally stimulus environment, and that's how we in the global north imagine a perfect sleep environment. But that's not how we evolved. In fact, the irony here is that we changed our sleep through time. About 1.8 million years ago, we began the process of whittling down our total sleep time as primates and securing REM. So we reduced the non-REM, we kept the REM, and the reason we could afford to do that wasn't in spite of the fact that we were social, it was because of the fact that we were a eusocial species living in camps and bands of about 25 to 30 adults in shared project of reproduction and survival. And so the acronym I've been working on is that of a shell. So if we start with the letter S, we have shelter. And what this does is it reduces the amount of temperature variability in our environment. So we have a more predictable environment. And then you have the hearth. This is H. And the hearth helps regulate temperature. And then you have E, which is environmental preparation. So you have mobile sleep sites that we've been shaping and selecting the best sites that have the greatest access to water or defensive crawls. And then L is lux, continual exposure to light, but good kinds of light. So the sunlight, and then after the sun goes down, to firelight and firelight only, unlike the blue light that we get bombarded with day to day. And then the final L is lookouts. When we looked at the sleep patterns of the Hadza, for example, it was incredibly rare for all individuals to be asleep at the same time, meaning you functionally have adults looking out for everybody at any given moment, which means that throughout the 24-hour period, you have this shell that allows you to go into deep, high-quality restorative sleep in the shortest amount of time possible. This whole thing put together is the reason why I think humans are incredibly bizarre and unique sleepers amongst the primates.
Wow, so it's our sociability that led to the shorter sleep. Now, you visited the Hadza in Tanzania. You talk about that in your book. It's a great adventure story. Did you try sleeping in one of their huts?
So I had my own tent. It was effectively the same square footage as a hut, but I have been in the huts. They build acacia huts, takes them about 4 hours. These 20 centimeter thick huts that are then insulated with, say, a animal hut. It's very simple, but quite effective. And then they sleep on 2 to 3 centimeter thick animal hides or textiles. And there aren't any pillows in this environment. In fact, when I asked them about, well, what do you guys use as pillows? They looked at me kind of weird, like there wasn't actually a word for pillow in the Hadsani language, Cook-based language. And they said, oh, just keeping your neck straight? Oh, we do that with our arms, or we shove a little dirt under our textiles.
Now, going a little further back in our evolutionary history, you also talked in the book about how you climb trees to see how our primate relatives sleep. Tell me about that.
Yeah, so I had the opportunity to work with Kevin Hunt, who was my doctoral supervisor, and he had ran a chimp site out in East Africa in Uganda, and I was really interested in this topic of chimpanzee beds or sleeping platforms, because great apes are really unique in the primates, and I'm including humans in this because a human is a great ape. We all build sleeping platforms. This is a proper bed, and they build one of these every night. And so all the great apes do this, and what I wanted to do was climb up into these nests, and sometimes my highest climb I think was about 22, 23 meters in a Cola gigantea tree, and quantify these chimpanzee sleeping platforms in situ to understand what they serve in terms of how a chimpanzee or any other great ape solves for the problems of sleep.
Wow. So did you sleep in one, or at least lie in one? What was it like?
Bob, I took a nap, a good siesta. I didn't have the courage to do it overnight, but it was quite comfortable, especially the ones that were built by the males. They were typically a little bit lower in the canopy. The females would go really high up in the canopy, and at my body mass, it was just a little bit less comfortable.
Wow. Well, what did this sleeping in trees do to our evolution over time?
So apes figured out a really ingenious way to get deep sleep, and there's this hypothesis that starting about 18 million years ago, once they built these beds, they could have deeper sleep, meaning they had potentially more REM. But they preferentially selected Cyanometra alexandri trees, so like 80% of the time, even though it was not readily available in the environment, meaning we could really get into the minds of a chimpanzee to see what kind of things they love in their bed. And this miracle tree was not only super resilient, and it had these beautiful, very thick, protruding branches. They were resilient under pressure, and the chemicals that you smell when you break it were repellent to things like insects, particularly Anopheles insects that carry Plasmodium, the parasite that transfers malaria. So it had all these properties, including it increasing warmth for the individual, that all these apes had this beautiful sleeping platform that solved for all these challenges that other primates didn't have the benefit of. So we had to solve for these things when we came down out of the trees into East Africa, and we started evolving in East Africa. We needed to figure out how to do what our chimp ancestors were doing in the trees.
Okay, so we got primates that sleep in trees with their comfortable nests. We've got the Hazda people who socialize, and there's always someone awake, so that lets them sleep with higher quality sleep. How does all of this compare to what we're doing today in our modern civilization?
Yeah, so there's this idea today that we live in a kind of sleep epidemic of sorts, that our sleep has never been worse, and that we are the worst sleeping cohort of Homo sapiens that have ever existed. And so we wanted to test this idea. And we went across 54 different societies, including the small scale societies that myself, my team, and my colleagues have been working with. And we wanted to see, is sleep actually better or worse in small scale societies compared to large scale agricultural societies, post-industrial societies? And we found something rather interesting. It was that in large scale societies, we're actually sleeping significantly longer and have